My voice is audible or not? Am I audible? Yes or no? Okay. So have you downloaded the ebook? So this is the Concrete Technology Theory and Practice by MS Sethi book. Okay. All of you please download it. It is easily available in Google. So you can download this book. Okay. Concrete Technology Theory and Practice. Okay. Uh, so first chapter is your cement. So here in this figure you can see there is a dam. Okay. And this is your Sardar Sarovar Dam. And this dam project is an interstate multi-purpose project of national importance. It is one of the largest project under implementation anywhere in the world. So this is a concrete dam actually. That's why it is showing. And this is the Idukki hydroelectric project, Kerala reservoir. This is the Bhakra Dam, which is across the river Sutlej, the construction, and it is the highest dam. It is located in Jammu and Kashmir. Okay, highest dam, high above deepest foundation. Okay, highest dam of India. Okay, so in this figure, here are some background of concrete technologies given. That means the structures which is made up of concrete. And here, some tallest high-rise buildings examples are given here. That one is your Eiffel Tower in Paris, Empire State Building, New York, Chicago, John Hancock Building. That's one World Trade Center. Sears Tower Center, Chicago. Petronas Tower, Kuala Lumpur. So these are the high-rise building. Okay. This is the Channel Tunnel Rail Link, UK. So the history of cement is first where cement is used in India. If we see the history behind the cement, these are used by Egyptians, Romans, and Indians. Okay, and the ancient Indian ancient construction, and it believed that early Egyptian mostly used the cementing material obtained by burning gypsum. Not much light as have been shown. Uh, Greeks, Romans, Indians, all they have used cementing material that is obtained from burning gypsum mixed with lime and sand. Okay, so these are the burning gypsum. Early history, modern cement. This is Joseph as Aspidin for cement works around 1826 at Kirkcaldy in Wakefield, UK. So the early history of modern cement, the investigation of Alze Vicat led him to prepare an artificial hydraulic lime by galvanizing an intimate mixture of limestone and clay. This process may be regarded as the leading knowledge to the manufacture of Portland cement. James Frost a also patented a cement of this kind in 1811 and established a factory in London district. These are the oldest surviving clean northern Kent, UK. Okay, where cement is manufactured first. This is the equipment where cement is the mixture of cement is produced here. The story of invention of Portland cement is, however, attributed to Joseph Aspidin, a Leeds builder and bricklayer. Even though similar procedures has been adopted by the other inventors. Joseph Aspidin took the patent of Portland cement on October 1824. So the history of cement is very old. Okay, and the cement first discovered by Joseph Aspidin, not discovered, that means manufactured by Joseph Aspdin. The fancy name of the Portland was given owing to the resemblance of this hardened cement to the uh, natural stone occurring in Portland in England. That's why the cement name is Portland cement. Okay, in this process, aspidin mixed and ground hard limestones and finely divided clay into the form of slurry and calcine in a furnace similar to a lime. Okay, so these are the historical things related to cement. Let's move to the main part of the cement. These are not so much important. Okay, first, see let us see the constituent of cement. How cement is, what are the chemical composition of cement? Okay, so chemical composition, this is very, very important. Chemical composition. Okay, chemical composition. The raw material used for the manufacture of cement consists mainly of lime, silica, alumina, and iron oxide. So mainly it has lime, silica, alumina, and iron oxide. These oxides interact with one another in the clean at high temperature to form more complex compound. The relative proportion of these oxide compositions are responsible for influencing the various properties of cement in addition to rate of cooling and fineness of grinding. Table 1.4 shows the approximate oxide composition. So these are the chemical composition of cement. This is very, very important. All of you, please remember what are the composition of cement? Lime, silica, alumina, ferric oxide, magnesium oxide, alkalis, and SO2. And mostly about 60 to 67% it contains lime. Okay, lime chemical formula is CaO, calcium oxide. So this and a little amount of alkalis are present, about zero point 0.4 to 1.3%. So Indian standard specification 33 grade cement and IS code is IS 269 1989 specifies the following. Okay. So these are the approximate chemical composition of cement. Let's move to the manufacturing process of cement. So basically, cement product manufacturing of cement includes two process. One is dry process, and another is someone is waiting in the lobby. Let me aid them. So manufacturing Portland cement. These are the raw materials required for manufacturing of what is the raw material? In manufacturing of cement, the raw material is limestone or chalk, and argillaceous materials such as shale or clay. Okay. The process of manufacturing of cement consists of grinding the raw material, then mixing the raw material in certain proportion, and then burning them. And then burning the raw material at a temperature of 1300 to 1500 degree Celsius. At which temperature the material sinters and partially fuses to form nodular shaped clinker. The clinker is cooled and ground to fine powder with addition of about 3 to 5% of gypsum. The product formed by using this procedure is Portland cement. Okay. There are two processes generally. One is wet process and another is dry process. Depending upon whether the mixing and grinding raw material is done wet or in dry condition. That means wet process and dry process means in wet process water is added and in dry process water is not added. That is the difference. For many years, wet process remained popular because of the possibility of more accurate control in the mixing of raw material. Okay, so this is the wet process. Flow chart of wet process. First, limestone and clay and addition of water. It will go to the mixing. After the grinding of all the materials, it will make a slurry. After that, burning. Okay, and the addition of 2 to 3% of gypsum is added in clinker, in ground ball, cement silos, and packing plant. The character slurry is sprayed onto the upper and rotary kiln about hot heavy hanging chains. So this is a diagrammatic representation of dry process of manufacturing of cement, where you can see that is limestone boulder from mines. It added. clinkerization section. And then 4, preheater is their raw material mills and rotary clean. Here the mixing is done is rotary clean. Rotary keel and cooler clinker silos. The cement mill section includes and some amount of fly ash or gypsum is added. Okay. Okay. In this figure, you can see a limestone quarry, raw material preparation, prime raw material, dry process. Water is not added in dry process. This is the raw mill where materials are mixed here. This is a real mill silo. After grinding, the powdered raw mix is stored in a raw mill silo where blending takes place. Blending is done by injecting compressed air. Generally, blending ratio is 1 is to 10. This powder material is fed to the this after this it will go to the rotary kiln. This is one showing the modern technological robo lab. Okay, so it consists of automatic sampling and changing station. One robot type structure is made, and it in place of man, robot will walk here. Okay, this type of technology is not available in India. Robot receiving samples and jumbo bag packaging. Packaging is done after uh, final stage. It is important to note that strength properties of cement are considerably influenced by the cooling rate of clinker. This fact has a late attracted the attention of both cement and manufacturers and machinery producers. The experimental results reported by Inke Gardner shown here. It can be seen from the table that a moderate rate of cooling of clinker in. Okay. The rate of cooling influences the degree of crystallization, the size of crystal, and the amount of amorphous material. And this one is not important. Hmm. And here, another major compounds of cements are there, which is very important. That is called box compound. Okay, box compound. These are the four compound usually regarded as a major compound are this one. Okay, and this first gives by RH box work and hence it is called box compound. What that was is tricalcium silicate, dicalcium silicate, tricalcium silicate, tetracalcium aluminoferrate, and formula is tricalcium silicate 3COSiO2, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrate. And abbreviation is this one. These are very important. All of you remember. Suppose in coming chapters, if I will tell like C2S, then you should understand, oh, dicalcium silicate. C3S, tricalcium silicate. C4AF, these are the abbreviations, short form. C4AS means tetracalcium aluminoferrate. So these are, and C3A, that means, 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 C3A means tricalcium aluminate. Okay? So these are the box compound. It is to be noted that for simplicity, shake abbreviation notation are used. C for CaO, S for SiO2, A for Al2O3, and F for Fe2O3, and H for H2O, and H for H2. Okay. These figures hold the schematic presentation of various compounds in clinker, tricalcium silicate, and Okay, again. Tricalcium silicate and dicalcium silicate are most important compound responsible for strength. Okay, these box compound are very important role in providing strength to the cement. Okay, next I will give you the heat of hydration. How after reacting with cement with water, there uh, is a enormous evolution of heat takes place. Okay, that means when cement is added with water, it produces some amount of heat. That is also that heat can be measured. Of that is called heat of hydration. Have you understood? So today we have learned about dry process, wet process, cement manufacturing processes have two process, dry process and wet process, and it has some chemical compositions and box compound. Box compound means major compounds of cement. That is dicalcium silicate, tricalcium silicate, tetracalcium aluminoferrate, and tricalcium aluminate. Atul Tator, do you have any question? Okay, how many 32 students present? Okay, thank you. Next class we will discuss heat of hydration and I will give notes. Okay, thank you. Is it interesting? I don't know whether it is interesting or not. Actually, cement concrete is interesting thing. I- Is it interesting? Why have you found it interesting, Atul? Can you tell me why have you found this interesting? What have you learned today? When you do the laboratory, I think laboratory these are again very mm, that one interesting things. When we do the various laboratory test of cement, to find out the strength of cement, to find out the aggregate strength, to make a concrete cube after mixing all the raw material in laboratory, and you have to break the cube after immersing in water for about 7 days. You have to take strength. Okay, so as soon as when you made prepared a concrete, it will in a liquid state. Okay, to harden make strength, or to get harder concrete, it will take time. Okay, after 28 days from the day of making the concrete, it will attain full strength. Okay, that is your call strength of concrete. And there are various grade of concrete: M20, M25, M30, M35, M45 for higher concrete. These are higher grade of concrete are used in bigger construction, like dam construction, bridge construction. Okay, in that construction, uh, M40, M34, oh sorry, M35, M40, M45, these higher grade of concrete are used. Okay, so after making the concrete for about 20, after 28 days, it will give full strength. And you have to spray water after making the concrete, whether it is a building structure, whether it is a beam, whether it is a column, or it is beam, column, slab. Okay, you have to spray water. That means the after making the structure, after removing the formwork means the supported structure, the temporary structures are provided in a for suppose in a column. Wooden temporary structures are given, isn't it? Wooden temporary st- mm, st- structures are used to make the columns, beams. Okay, these are called formwork. After removing the formwork, it should be removed after 1 days, after 2 days. In case of slab, we should remove the formwork after 7 days. Okay, like that we have various specifications depending on the type of structures. Okay, so I will continue in the next class. Thank you.